A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
You ever get that feeling where your brain is moving at 100 miles an hour? You have this perfect sentence formed, and then you look down at your hands and realize you are basically a bottleneck? We speak at about 150 words per minute, but most of us are lucky to hit 40 or 50 on a keyboard. It is a massive input gap that has been haunting computing for decades.
It really is the fundamental friction of the modern era. I am Herman Poppleberry, by the way. And today's prompt from Daniel is about the engineering hurdles of trying to close that gap on Linux specifically, using modern multimodal AI. It is a timely one because we just saw the release of GNOME 50, codenamed Tokyo, on March 18, 2026. That release was a bit of a watershed moment because it effectively ended the era of legacy automation.
Right, the Great Tokyo Cutoff. It is funny how the Linux community prides itself on freedom, but then the developers go and implement what people are calling the security through amputation model. You want to automate your keyboard? Sorry, we cut that arm off for your own protection.
That is exactly the tension. In the old days of X11, you could have a simple script or a small voice-to-text tool that just sat in the background, sniffed every keystroke you made, and injected text wherever it wanted. It was incredibly powerful and, from a security standpoint, a total nightmare. Any malicious app could record your passwords or hijack your input. Wayland changed the game by isolating applications by default. Now, if you are building a voice-to-keyboard tool, you are not just fighting the AI latency, you are fighting the operating system itself.
It makes me think of those old spy movies where the hero has to get through a high-security vault, but instead of laser grids, it is just a bunch of polite Canadian border guards asking for your identification every time you try to type the letter A. How do developers actually get around this now, without just reverting to X11 like it is 2010?
They have to use these new, more structured protocols. The standard now is move toward libei, which stands for emulated input. It is a library that allows a client, like a voice-to-text engine, to send input events to the compositor, but only if the user gives explicit permission. It is a much cleaner architecture, but it adds a layer of engineering complexity because you can no longer just throw characters at the screen. You have to negotiate with the Wayland compositor using protocols like Virtual Keyboard v1 or Input Method v2.
I love how the solution to a simple problem like typing with your voice involves 4 different libraries and a formal negotiation. It feels very on-brand for Linux. But even if you get the plumbing right, you still have the problem of the text actually showing up. I have seen some of these newer tools like VoxType or WhisperWriter moving away from the old XDoTool hacks.
They had to. XDoTool is basically dead on modern distributions because it relies on those X11 holes that are being plugged. The modern replacement is WType. It is a Wayland native tool for injecting text, and it is significantly more robust. It handles non-ASCII characters and complex scripts like Chinese, Japanese, and Korean much better than the old hacks ever did. But even with WType, the engineering challenge is the handoff. You have the AI model generating a stream of text, and you have to pipe that into the active window in a way that does not break the user's flow or cause race conditions.
You mentioned the stream of text, and that is where the real magic and the real frustration happens. We have all been in that position where you are talking to a voice-to-text tool, and it is just sitting there staring at you, waiting for you to finish your 3-minute monologue before it decides to type a single word. That is not a conversation, that is a deposition.
That is the difference between batch processing and streaming. If you want near real-time input, you have to go with a streaming architecture. But here is the catch. Streaming models suffer from what I call a context deficit. When you use a batch model, the AI looks at the entire recording at once. It can see the end of the sentence to understand the beginning. But in a streaming setup, the AI is making decisions on the fly with maybe 5 to 20 times less context than a batch model.
It is like trying to finish someone's sentence when you have only heard the first 3 words. You are going to get it wrong a lot. I imagine that is why we get those hilarious homophone errors. The AI hears read and has to decide immediately if it is the color or the verb. Without the rest of the sentence, it is just a coin flip.
It really is. DeepGram released some data in February of this year showing that streaming models often make early decisions that they then have to correct. If you are typing into a terminal or a text editor, you cannot easily go back and erase the last 3 words without it looking janky. So, developers are faced with this brutal trade-off. Do you wait longer to be more accurate, or do you output immediately and risk looking like you do not know the difference between there, and they are?
I will take the jank if it means I do not have to wait. But then you have the filler words, the ums and uhs. If I'm dictating an email to my boss and I say, I think we should, maybe look at the, quarterly projections, I do not want the uhs and ums in the final text. But if the tool is streaming in real time, how does it know to cut those out before they hit the screen?
That has been one of the biggest engineering hurdles. Traditionally, to remove filler words, you need a look-ahead window. You wait for the next word or two to see if the current sound is just a vocal tick or a meaningful part of the sentence. But every millisecond you wait for that look ahead is a millisecond of latency the user feels. It is the digital sandwich problem we have talked about before, that awkward gap where the technology is just slow enough to be annoying.
The digital sandwich. Still the best name for that phenomenon. It is like being stuck in a conversational waiting room.
Well, we are finally seeing some breakthroughs there. Earlier this month, around March 8th, a tool called WhisperFlow introduced something they call the Actually Override feature. They are using a very small, highly optimized large language model as a post-processor. It sits at the end of the pipeline and scrubs those filler words in under 300 milliseconds. It is just fast enough that your brain doesn't register the delay, but the resulting text is perfectly clean.
300 milliseconds is the magic number, right? That is roughly the speed of human reaction. If you can stay under that, it feels like magic. If you go over, it feels like a broken toy.
And the architecture of these models is where the real battle is happening. You have the open source side with OpenAI's Whisper, and then the proprietary side with things like DeepGram Nova 3. They take fundamentally different approaches to this problem. Whisper was originally an encoder-decoder transformer designed for batch processing. It is brilliant at accuracy, but it was never really meant for streaming.
But people have hacked it to work, right? I see whisper.cpp everywhere in the Linux world.
They have, but it is a bit like forcing a marathon runner to do a 100-meter sprint. You have to chunk the audio into small segments, process them, and then try to stitch the results together. The problem is that Whisper often suffers from hallucinations at the end of silent segments. If you stop talking, the model gets confused and starts inventing text or repeating the last word over and over. Developers have to write these complex, VAD, or voice activity detection filters just to keep Whisper from losing its mind during the pauses.
It sounds like babysitting a very talented but very erratic toddler. No, Whisper. I did not say thank you for watching 5 times in a row. I was just breathing.
That is a perfect description. Now compare that to DeepGram Nova 3, which came out in February of 2026. That is a native multimodal model. It does not just transcribe text, it processes the audio signal directly as part of its internal representation. It understands prosody, the rhythm and pitch of your voice. So, it knows that a long pause after a certain tone means the end of a sentence, not an invitation to hallucinate. They are hitting a word error rate of about 5.26% with sub 300 millisecond latency. That is the benchmark everyone is chasing right now.
5% error rate at that speed is wild. That is better than some of my friends after a couple of drinks. But let's talk about the context-aware stuff Daniel mentioned. This feels like the next frontier. If I am in a terminal, I want the word grep to be spelled G-R-E-P. If I'm in a cooking app, I want it to be prep. How does the tool know where I am without becoming a piece of spyware?
That is the big controversy in the Linux community right now. To be truly context-aware, the voice input tool needs to know what application is in focus. In the old X11 days, you could just query the window manager. In Wayland, especially with the strict isolation in GNOME 50, that is much harder. Developers are having to use things like eBPF or specialized portal APIs to get a hint of what the active window is. Once they have that, they can adjust the vocabulary weights of the AI model.
So if it sees I'm in Visual Studio Code, it bumps up the probability of words like function or variable. And if I'm in a browser on a news site, it focuses on general vocabulary?
Precisely. And in 2026, we are seeing this go even deeper. Some of these tools are now reading the text already on your screen to provide even more context. If you have a variable named user_buffer64 in your code, the AI can actually learn that on the fly and transcribe it correctly the first time you say it. It is bridging that gap between the machine's state and your spoken intent.
It is basically a mind-reading keyboard at that point. But I can already hear the privacy advocates screaming into their encrypted pillows. You have an AI model that is listening to your voice, looking at your active window, and reading your code. That is a lot of trust to put into a piece of software, even if it is open source.
It is, which is why the shift toward local inference is so important. With things like Whisper Large v3 Turbo, you can run a very high-quality model directly on your own hardware, especially if you have a decent GPU. You get the speed of local processing and the security of knowing your voice data isn't being sent to a server in Virginia or California. That is why the Linux community is so obsessed with Whisper despite its streaming quirks. It represents digital sovereignty.
Digital sovereignty sounds great, until you realize your laptop is loud enough to take off, because the GPU is pinned at 90% just so you can dictate a grocery list.
Fair point. But that is where the engineering is heading, optimization. We're seeing models that are being quantized down to 4 or 8 bits, running on specialized NPU or neural processing unit chips that are becoming standard in 2026 laptops. The goal is to have that always-on voice input without killing your battery.
I think about how far we have come since we talked about the speed of thought in episode 1479. Back then, we were just starting to see the shift from how big is the model to how fast is the inference. Now, the battle is entirely about the interface. The AI is smart enough. The problem is getting the AI's thoughts into the computer's buffer without a bunch of technical friction.
It is a classic engineering problem. You solve the core physics, the AI's ability to understand speech, and then you spend the next decade solving the plumbing. And on Linux, the plumbing is currently being ripped out and replaced with Wayland, which makes it both the most exciting and the most frustrating platform to develop for right now.
It is the Linux way. Why do something the easy way when you can invent a new protocol and spend 3 years arguing about it on a mailing list? But honestly, the progress is impressive. The idea that I could sit down at a GNOME 50 desktop and have a conversation with my terminal, with sub 300 millisecond latency and zero filler words, that feels like the future we were promised.
It really does. And for the developers listening, the takeaway here is that you cannot ignore the OS layer anymore. You can have the best streaming STT engine in the world, but if you do not understand libei and Wayland's input method, v2, your tool is going to be useless on every major distribution by the end of this year. The security through amputation model is here to stay, so we have to build better prosthetic interfaces.
Better prosthetics for our amputated OS. That is a dark but accurate metaphor. I also think for the average user, the takeaway is to look for tools that are context-aware. The difference between a generic voice-to-text tool and one that knows you are writing C++ code is night and day. It is the difference between a tool that helps you and a tool that you have to constantly correct.
And if you are sensitive to latency, keep an eye on those multimodal models like Nova 3. The shift away from the old encoder-decoder architecture toward native audio to intent processing is the biggest leap in accuracy we have seen in years. It is what finally makes real time feel like real time.
I am still waiting for the model that can filter out my bad ideas before they get typed. Actually, Korn, don't send that tweet. It is 3 in the morning and you are hungry. That would be the ultimate engineering achievement.
We might be a few years away from the bad idea filter, but we are getting closer to a world where the keyboard is optional. And for a lot of people with accessibility needs, or just people who are tired of carpal tunnel, that is a huge win.
It really is. It is about making the computer adapt to the human, rather than the other way around. We have spent 40 years training our fingers to dance on plastic keys. It is about time the computer learned to listen.
I think we have covered the landscape pretty well. From the security hurdles of GNOME 50 to the architectural differences between Whisper and DeepGram, it is a fascinating time to be looking at input methods.
It is a lot deeper than I thought it would be. I figured it was just microphone goes in, text comes out, but as always, the reality is a lot more complicated.
It always is. If you want to dive deeper into the early frustrations of this, definitely check out episode 1218, where we talked about why real-time voice typing used to fail so miserably. It gives you a good sense of just how much ground we have covered in the last few years.
And if you are interested in the broader shift toward high-speed inference, episode 1479 is a great companion piece to this one. It covers the hardware side of how we actually run these models at the speeds we are talking about today.
Thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes.
And a big thanks to Modal for providing the GPU credits that power the research and generation for this show. They make it possible for us to dive into these technical rabbit holes every week.
This has been My Weird Prompts. If you are enjoying the show, consider leaving us a review on Apple Podcasts or wherever you listen. It really helps other curious minds find us.
You can find all our past episodes and the full archive at myweirdprompts.com. We are also on Telegram if you want to get notified the second a new episode drops. Just search for My Weird Prompts.
We will see you next time.
Keep your latency low and your context windows wide. Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow to